Live. Okay, welcome everybody. We are live for a calculator-based bit of practice. Been working over the last couple of days to do what I can to bring about a calculator paper. So a set of questions that will be likely on the calculator paper, and in some regard because they need the calculator. I will be using this calculator here. This is the Casio FX, just up here. Let me start writing, it would be useful. The Casio FX 991EX Class Whiz. I feel like it's a bit late in the day to start changing calculators, although I do have with me the Casio CW, which does have, its own little extras. One of which is if you don't like drawing number lines, then you have the ability to draw the number line visually on the calculator. How much can a calculator do before you're not thinking is a big question of our age. But at least you're allowed these in the exam. So I recommend this being probably one of the best ones that you can have, that you can actually take into a GCSE exam. Can't have one with an algebra. Just double check that it can't store things or use algebra. I know it looks like it could do algebra here with the calculus, but it can't. This thing here is numerical methods that uses a form of iteration to achieve. So, okay, all good to go in the exam, which is fabulous, of course. Testing the sound. HA, hi, how are you doing? It is that time of week. I thought I'd come a bit earlier today, considering the other people. And I hope the sound's okay. HA, hi. I have a new microphone. I have one of those fancy condenser ones. Borrowed from work currently, but I'm thinking of getting one. Depends how well things go. Shall we get started? Last time I was here it was 2 hours. So I don't want to do that again. I want to stick to an hour if I can. And looking at this, there's not as many questions as last time. I'm learning from that. And we'll get started as soon as I double check this. So I'm just giving people a chance to come in. No more than 3 minutes. Okay, so looking online, we've got the Pearson Edexcel. They're usually all done at the same time. Wednesday the 7th of June. Okay, so that's next Wednesday. So I thought this stream will give people a chance to have a bit of practice ahead of time, not the night before. And these are brand new questions. You won't find them anywhere else. They are inspired by the Edexcel style. And you can watch them again, of course. And you'll find a whole new set, a whole new bunch on Patreon if you want some more, which is something like £1 a month. It's not very much. Got some really exciting merchandise on there. I like that they send you samples as well. Might give them away for competitions. The first 2 sign-ups for Patreon for just the £1 a month tier, maybe I'll send a merch for free. Okay, having a look here is the calculator. I could refer to this at any time. Bring it with me, for example. As we come down, so I can show you what it is we're doing, or what I'm doing, or what buttons I'm pressing. So I'll keep that cut, I think, along the way. Let's get going. If you have any questions along the way, just let me know. I've got the chat open and I will endeavour to answer anything you need surrounding the exam, or just have a debate about what might be occurring. Okay. Let's go for this pen and see how it works. That seems fine by me. Okay, so remember that with the calculator papers, there are some crossover too. So you have a crossover on topics like this. They could appear on both. So you have to be prepared. You will see some questions that clearly you have to have a calculator. You can't deal with these decimals in the right amount of time. And the calculator does have a number of tricks to it as well. So be aware of what's available. So first question, and obviously you can look ahead and see some of the questions here. They start off fairly easily. First one says, solve 16 subtract 4, 7 plus x is less than 8. So it means we're finding the set of values that satisfy x. So what numbers could we put in here so that it was still less than 8? And as you know, we just treat this as an equals. And we rearrange it as such, keeping it all the same. There's a couple of schools of thought though. Some people like to expand the brackets when they see them, and some people, they like to instead move everything around. So as long as you're not multiplying or dividing by a negative number, then this inequality is going to remain as it is. So if we add this whole thing to the right hand side, like so, it's a bit of a slowdown on this one. I don't know what it is. So if it's a little bit jerky, I'm sorry. There's 8, and if we take away 8 from both sides, we've still not violated the law of multiply and divide by negative. So on the left hand side, we'll keep the 16 there, but we'll have taken away the 8. So I did two things at once there. I added the 4, 7 plus x, added that to both sides, and then I took away 8 from both sides. So those are two operations. We end up with this. The more you do without, having a line in between, the more potential for error. And no one's immune from error. At this point, it's probably okay to rearrange like this. I've not violated any law by dividing by 4. It's a positive number. And then the last thing is we're going to take away 7. So what this will lead us to is 2 subtract 7. If we take away 7 from the right hand side, we end up with x. Fantastic. This will allow us to write the answer over here. And we could keep it this way round because you don't want to make errors, right? You want to just know your boundaries. You want to know you'll be comfortable with what's going on. But if you did want to, because this makes you feel comfortable, just make sure that the inequality faces the correct way. So this is every number that's more than or equal to negative 5. It depends if they're after integers, which are whole numbers, or whether they're strictly the entire range of numbers. Some interesting question, I suppose, is what is the first number that is larger than negative 5? The first number. And we're going to have some betting, aren't we? Some in the chat, perhaps. Someone's going to say negative 4. Perhaps you would be right if it were the integers. But we want to go for accuracy. So the first number bigger than negative 5. I know some people are going to say negative 4.5. Get in there. Negative 4.9. Negative 4.9 recurring. Can we go any more? There is a bit of maths that says that this is equal to this. But we'll go there another day. Yeah, so basically it's a tiniest little bit more. Negative 4.9 recurring, conceptually. On a number line below, show the set of values for x for which this is true. Golly gosh. Well, it doesn't follow on from the previous one, but it's still inequalities, and we have to show it on the inequality line. So this is one of those equations which I don't suppose we see too much, but let's say like this. You might be happy with an equation that looks like that. But if this is also equal to some other quantity, it means that all three things are in equilibrium. Therefore, when we add to 1, we add to all of them. And it's not just the one side versus the other. That's what you're used to. We do the same thing to all of them. So the aim is still to get the x on its own. I'm just going to change these inequalities back now. And they must remain the same. So if the aim is to get the x on its own, it's the same. We focus on getting rid of the things around it. And really we focus on, wow, look at that anomaly. That's something to do with the mat that I have. It's a fairly cheap one. It works well most of the time. So when we're rearranging, oh gosh, 2 in one go. We're going to go something like negative. We're going to backwards from BIDMAS, okay? So thinking about this, it would be ideal if we did, get rid of the brackets first, but we can't because inside the brackets, it's got trapped by this 2 on the outside. So in essence, we have to go for the multiplication first when rearranging. Let's show you working out as you go along. So the first one is divide by 2, everything. -5. Something is going to happen later. We have to draw it. So probably have to move this somewhere. And then we're going to add 4. So maybe I could put that. Let's just do it all here and then I'll move it in a second. -5 add 4 is -1. And then we add 4 to x, we just get our x. And then -2 plus 4 is 2. Now clearly this needs to move out of the way. We don't go as high as 6, so we can stay there. And we have to draw this thing. Now, as I said, the calculator, it's called the FX85CW. And it's not on the 991 CW, but on this one, there's this little thing called a toolbox. Let me just have a look what it's called specifically. It's called a math box, actually. So on this one, a couple of dice, and it's called Maths Box. I don't suppose anyone's rushing out to buy this new calculator, but if you have it already, that's what it is. And in Maths Box, you will find that you can input inequalities like this, and it will put it onto a number line. You just have to copy it. Bit of a strange one. In light of that, I don't imagine it to be, they might do something clever that it's already drawn. Yeah, in the exam, they don't want you to have an unfair advantage with a calculator. So imagine that it's already drawn and you have to interpret it, and maybe you have to draw this. Sorry, not draw. You have to write this expression. Maybe based on the inequality, which will come out to something very simple like this. You have to show that this is true. So in that case, you do the opposite of what we were just doing. We would, I don't know, take away 4 from both sides and then times by 2. Maybe something like that. I'm just spitballing. Would it be a question? It would like could be boundaries. So if you talk about bounds, we could definitely do a quick one on that one. So if you've got like 7.1 centimeters, and this was rounded to the nearest 1 decimal place. I do have a trick way of doing this, but I also have a conceptual way. I mean, I think we should look at the pattern. 7.1 has been rounded. Technically, you could call it 7.10, and that's useful for seeing a pattern. Bear with me a second, that's really annoying. So I don't know if that was planned, but he's come back 3 times today trying to sell products from door to door. I feel like it should be not allowed. It's disrupted this live stream. Hey, here we are. 7.10. We were talking about boundaries. So 7.10. Imagine this 7.10 is 7.1, and we want to find the upper and the lower bound. What you'll do by adding this extra 0 is notice that you get a 2-digit value at the end, and you could just add 5 to it. So you got 7.15, and then if you take away 5 from these last 2 digits, you get 7.05. And these are the upper and lower boundaries. What you don't appreciate is, what most people don't understand is, why is it 7.15, right? Because that should round up to 7.2. And that's a very good point. But this is a boundary. It's written this way for ease. We know that the upper bound, it never really hits it, and the lower bound, it does. So to be precise, they introduced the idea of writing the boundary as inequalities. So if we suppose that the letter, the number over here was a y, then we would say that it would never really reach 7.15, but it's everything right up to it, the smidgen smaller. And we do include the lower bound as something possible, because you can see the lower bound does round to 7.1 using the standard rounding methods. And that's where inequalities would come in for sure. Definitely something like that. This little add 0 works for quite a lot of them. And it is really useful. But if you can't, most people find, let's do 8.17. Most people find that doing the lower bound is the easier one first, because it just makes sense, right? So this is rounded to 2 decimal places. That means that it was 8.173, or maybe it was 8.175 as a maximum. No, that would be too much, as you can see. So I'm just like, if I'm ever stuck, I'm playing around with it, right? It could have been 8.170 or 8 over here, 0.169. So now we're going down the other way. 165. That's probably the lowest if we're talking about cutting that off. So just playing around with it will help. But the lowest is usually easier than the upper bound, because it's clear and concise. There's no confusion about this being 7.14 recurring, 149 recurring, and it just seems to be easier. Once you realize that this is the lower bound, it's a sort of symmetry. So if you can see now, it's like you can spot that it was 165. It's a sort of a subtraction of 5. And I can add my 0 to here if you want to look at it even better. This number is 165. There's 170. So your upper bound will be 8.175, because I'm just adding 5 onto the 170. And for sure, that could be a question. Now, let's take these two. Let's say that they were, we're totally going off this particular question, but it's fine. Let's say that they were the dimensions of this side. Let's call this number n, and let's call this n. You could have something like this. Another way they get caught out is if you want to maximize the area, right? So how do you do that? Well, we're going to use the value of m, which is the upper bound, and multiplied by n. Well, I can't use capital, can I? It's not very fair. Multiplied by n, also upper bound, because multiplying two numbers together will give us the bigger number will give us the largest outcome. This is a slightly bigger number than the one below. And that's all very fine. If we were trying to minimize the area, we would pick the lower bounds, right? And that's all very fine. And I feel like that kind of scenario definitely could come up. The other one, however, is when you're talking about m over n. And this is really the inverse relationship, okay? So inverse proportion. We have a number that we want to maximize the output of this. And we think about fractions. The best way I've always seen, if we have a set of numbers for maybe something like this, and we're trying to put these into a fraction. So one of them will be the numerator, one will be the denominator. Which would you pick to put where? And you can't use the same number twice. What would you pick if you wanted to find a maximum value here? You're doing 1 divided by the other. So if I did 1 divided by 20, that's splitting 1 even smaller. That's not going to be any good. Clearly we can see that to maximize this, we would want the biggest number divided by the smallest number, and that would give us the largest outcome for m divided by n. So in fact, if we just go back and, well, actually no, we'll add it to this. This was a case of picking m, the largest, so upper bound, but then on the bottom, the n had to be the lower bound version. Because you're dealing with hypotheticals, these are not known, but we do know if we pick the biggest or the smallest, this will give us the best outcome. So this is where you have to be careful. I think the other one is 1 over m over n. You gotta be careful with ones like that. Remember, that just flips it, right? So n over m. But just be aware that it's not always so straightforward on which one you're going to choose, but try and make it clear where you can go to get your upper and lower bound for each of those questions. Right. Gosh, where were we? Actually, it's not always straightforward to use this. Delete, because I've always got my calculator, haven't I? I'll get the rest from there. Do we need that? No, that was for another one. Okay, so looking back at this one, we have an inequality to put on the line. You put the actual numbers exactly where they are. So we've got a circle there, and we've got a circle at 2. Lovely. Now, some of you screaming, hey, you haven't colored one in. Not yet, but I will. I like to think of these as empty vessels. And so what you're looking at is the difference between an inclusive inequality and a strict inequality. And the one that's inclusive will include, I don't know, what do you want to call it? Soup in the bowl, paint in the tin. It's going to include the color. And then we join them up with a straight line. And this is going to be hard because the device I'm using, but you'll forgive me, I know. All right, so that's how we draw it on the number line. Some of the harder ones to draw on a number line are when they invert it. So when x has to be, let's say, more than, let's keep the same numbers, 2. But it's also in union with x being, I don't know, say less than -1. Okay, so in this case, we have some region defined by everything more than 2, and then a region in union with everything that is less than 1. So in that case, we don't have connection here. It goes outwards like this. So there can be a gap in the middle. Don't draw the arrow, that was just me. There can be a gap in the middle. Anyway, talked a lot about this. Let's have a look at chat for a second. I bought the CW but returned it because I didn't like the circular buttons. Oh, bless. There is something about this new calculator which does not... It doesn't register, right? I asked Casio, can you send me a calculator? I test it, I'll, review it for you. And they didn't. So now I'm totally impartial. I can say that the calculator, I know I would probably want to get used to it. There is some petition online for saying you don't like it, bring back the old one. I don't think that's going to happen. The display is nicer, but everything is, it feels like a mobile phone. because there's less buttons out the front, right? And I think that's the whole point of what they were trying to achieve. It's sort of like navigation button based with a back button that you use frequently. I tell you, something that's really frustrating is the format button. I mean, for a start, the meme of S to D is gone. But the second is that every time you have an answer, because nobody cares to have it in standard form, when you're doing numerical analysis particularly, you have to go to format and change it to a decimal each time you do a new calculation. Don't like it. So that's lost marks for me. And you're right. When you're about to take an examination, you don't want to change too much at the end. It's really like steadying the ship. Imagine it's like you've got a bow and arrow, and you're very slowly and how should I say it, with discipline, lining up the shot. You take a deep breath. You have to be calm, and you line it up. And everything has to be just right and at peace and at balance, and then you let it fly. It's a similar sort of concept, I think. Too much panic, it stops your aim. All right, let's move on. We talked a lot about that, so that's really useful. People are going to get value out of this, which is extra to the questions. Question number 2. Write 68 as a product of its prime factors. Oh yeah. There is a way of doing that on the new calculator, funnily enough. So if I write 68 and then I press execute, EXE, so I'd probably write this down as I do it, 68 and then EXE for execute, and they are round buttons now. And then I can go to format button, which is down the bottom. It's actually in capital letters, but whatever, Trevor. We're going to go back like this. It's like that, the format button. And then we're going to go down. So down one and down again. And then you get this thing called the prime factor button. And you press enter. And it tells me that it's 2 squared times 17. So the calculator can double check it. For a 2-mark question, you might want to do a little bit more than just use your calculator. So, as we know, this whole method rests possibly on some sort of tree. So, 2 times 34, 15, 16, 17, as we thought it was. So, we underline the primes as we go, and we get 2 squared times 17. Okay, so we've done that one. Fairly straightforward, but that will come back, so be aware of it. You lost a mark because you forgot to colour it in. It's just a classic. It's just classic. Find the lowest common multiple of 68 and 90. Oh. Again, the new calculator does this in its tool button. Not that I'm going to go through that now, but you can find a number of things, including dice rolls, which are present their own problems because you still have to get the marks in the exam, right? Okay, so we've done 68 already. That's 2 squared times 17. And we're not going to worry about big numbers because we have a calculator. Yippee. Now we're going to do 90 as a product of its prime factors. So to get the mouse out of the way. 2, 45, 9 and 5, 3 and 3. So we have 2 times 3 squared times 5. All right, so everyone has their own way of dealing with this. Probably the most clear visual way of dealing with it is some sort of Venn diagram. And I appreciate you can do this without drawing the Venn diagram. For me personally, in the exam, I want these things to lean on, so I'm not going to make mistakes. There are ways for me to double check things and keep it organized. So I'm going to do that. So first of all, we're looking for what we've got in common. We can see we have a 2 in common here, so that's going to go, but the rest, nothing else. So 2 times 17. And over here, we have 3 squared times 5. Okay, so that's all really cool. We can find the HCF from here. So HCF is 2. That's the highest common factor. That's not very good, is it? Not very many numbers go into these two. But the LCM is going to be a product of all of these. And I'll just circle them all of these multiplied together. Okay, calculator at the ready, because that's what we do. 2 times 17 multiplied by 2 multiplied by 3 squared, which I'm going to just say is 9 times 5 for an easy life. And we get a horrific number. LCM equals 3060. Be careful my zeros don't look like 6, right? So 3060 is the LCM of those two. And the calculator at the ready. You would not have had that on a non-calculator. Not that we care anymore, right? Every exam in your life from now on, if you're doing maths, is calculator based. Except if you retake. I can't help you there. Okay, let's go on to the next questions. Lots of fancy questions here. I haven't actually done them myself. We'll get through them together. And I'm sure they'll work. Number 3. I might give you a bit of time to look at it, because the nth term of a sequence is 2n, open bracket, 2n minus 1. And the nth term of a different sequence is blah. It's another, looks like a quadratic. Both quadratics. What sequence terms are in both sequences? I had to write sequence terms rather than terms. I just wanted to make it clear, but now I regret putting sequence. So I'm going to edit that for the final cut. So, what's going on here? Oh, there's a problem. Okay. I don't know what's wrong. It's not writing. Huh. That whole page. Can we do a different page? Okay, that works. We're going to skip those questions. And we might come back to them later. Never mind. Maybe I don't know, have to reset that page. Question 5. In the process of creating an instruction manual for a 3.6 meter ladder, a team decides it's more user-friendly to include the distance between the ladder's base and a wall when it is leaned against it. To ensure safety, the angle between the ladder and the floor must be 70 degrees. Okay. Determine the distance from the wall to the ladder's base. Give your answer to correct 3 significant figures. Now with this one, what's that about? There's a lot of writing. I think this is going to depend on drawing the diagram. And I didn't do the diagram on purposes because I wanted that to be something that added a little bit difficulty. So you have to imagine right now we've got a ladder that's 3.6 meters. And we are looking to find the distance between the ladder base and the wall. And whenever a ladder goes against a wall, and a wall is most typically flat, you know, like perpendicular to the base, the floor, then we're going to create some sort of right angle triangle. Now let's see if this is clever enough to recognize the right angle triangle. It's kind of okay. Let's just rotate it because it's slightly off. I don't know if I like it. I'm going to try again. Okay. Oh, much better. See, there you go. I don't know what I did there, but it worked better. And we're going to switch to red. So let's say here is the wall, and this is the technical way of drawing a wall. And it's going to create an angle. So that this is the ladder here, the 3.6 meters. And a team decides it's user-friendly. Yep. So here we've got that the angle between the ladder and the floor must be 70. So this here is 70 degrees. Okay, so right angle triangle here. Determine the distance from the wall to the ladder's base. So in essence, we need to find this. We're going to give you answer to correct to 3 significant figures. So hopefully we're thinking right angle triangles plus angles. So that leads us to think trig. Yes, indeed. Let me get rid of this so I can see chat. I need to put that up so I could see what might be going wrong. Where's my mouse? There we go. Okay, back. So we're thinking trigonometry, and we're going to label these sides. I'm going to go for a different color. This one here being the opposite, not interested. This one being the adjacent, because this one is the hypotenuse. And under all of this, we are going to decide which ratio to use. We must remember SO, CA, TOA. Wow, look at this lovely Fourier. There's something weird going on. It might be the mouse is too close to... Yeah, it might have been that. So let's move right away. SOHCAHTOA, and we decide what we're going to use. Clearly the adjacent is involved, the hypotenuse. So we realize that we've got 2 elements from the cosine. So we've got cosine 70 is equal to the adjacent, which we know is x, all over the hypotenuse 3.6. Okay, so this encourages us to 3.6 multiplied by cosine 70 to give us the unknown. This is where we have the calculator on, and we must make sure that we have in degrees, okay, because we're dealing with degrees, not radians. At GCSE, you haven't got no business doing radians. If all else fails and you don't know how to do the degree thing, make sure that you can reset your calculator. Shift reset, which is above the number 9 key. All, press number 3, and then press equals and the AC key, and then it's like lifesaver. So make sure you can do that. So that should bring it back to degrees. 3.6 multiplied by cosine of 70. Okay, so we get a long number. I'm going to just change that around so we've got x on the left is 1.234, no, 1, 2, 7, etc. We don't need to go much further. It says one of those things where you can get and lose a mark, right? You've got to round it. It's easy to just leave it. So 1 point, and there's our cutoff point there. So really, that 1 is not going to affect it. So we've got 1.23. And this will be in meters, okay, because the ladder was in meters, and therefore so is everything else. And that's 3 significant figures. Okay, so that's turning a real life scenario into, into a mathematical diagram. Next, question 6. I'll give you time to have a look at that. Still can't move that. I'll leave it. The formula 1 over h equals 1 over b minus 1 over p is used by opticians, so it is. Okay, so if it's used by opticians, what is it used for? We don't know. This is a pair of sunglasses from the future. Make H the subject. That means we need to use operations, do the same thing to both sides, maybe a few tricks, to get H on its own. Currently, H is not on its own. It's the denominator on the left, and that's a pain. If we multiply both sides by H, it's going to have an effect on this whole thing on the right. So 1 equals H, 1 minus B minus 1 over P, something like that, which we totally can do. And I would say move that then. I mean, if you're going to do this, make sure that it goes over to the other side as a whole. We can actually save ourselves a wee bit of time here. That's 1 over 1 over B minus 1 over P. There we go. H on its own. I wonder if we change this around. So let's say that it's getting B on its own, whether that would be any easier or harder. May as well go for broke and do them all. We can see that in fact it would be the same sort of scenario, wouldn't it? We'd move that B over like that, and then we divide like so. And it must be the same for the other one as well. I guess we could get lost in trying to sort that out. So like have a common denominator. And I think that it would probably be harder if how do I put it? Probably be harder if we had things like what do we say? If these were H as well, that would be much harder. We can have a little go at that one because we may as well see that variation. But let's have 1 over H equals this now P minus B over BP. We don't know why I'm doing this, to be honest. I'm just showing what's possible, right? So I feel like this is the trap that you could do. And here's another little trick for you. If you have a fraction on both sides, a pure fraction, okay, so none of this how we started, but one fraction and one fraction, you can flip both of them. So we have H over 1, but we can leave it as H. And then that would be BP over P minus B. So that's pretty cool. It depends really what format they want it, right? So if you're asked to write it in this format, you're going to have to do the combining first. If you strictly want to get H on its own, that's good enough. If they ask you to simplify it to something like this, well, then that's what you're going to need. You have to put it into one fraction. I'd like to explore if it was H over here as well. So let's say we had 1 over H equals 1 over H minus... No, that's too easy again, because we just moved the 1 over H from both sides. In fact, that's invalid. Maybe H over P. That's probably a little bit harder, but that shouldn't be P, because it's too easy to combine the fractions straight away. What else have we not got? H over P and B. Let's try that one. Okay, maybe this is a bit more of a problem because we have to get H on its own here. What would you do? Like, to be really clever, to be doing it quickly is not really a nice way. It's more a case of combining these. So we'd want PB as a common denominator. Now that's going to add a B, so we'll have HB, and that's going to add a P, so we'll have P on the top. 1 over H is equal to HB subtract P all over PB. Anomaly. And then because the aim here is to get h, right? So we're making a bit of a pig's ear of it. Let's put the PB over there. Might not be possible to do this, but we'll try. PB equals h squared b minus HP. At least we have two different h terms now. I think we're finding that this is not possible. So there are only a limited ways of doing it. So for example, we could take h out, but we'll still be left with HB like we did earlier. We can't separate these. So this is not a possible scenario. Okay, cool. Just so I knew. Yeah, so you've never seen a rearranged question like this. It's nice to know that you've seen it at least, that it won't be a shocker. At the end of the day, it's some fractions, right? Take away. We could rearrange it so we add 1 over p, like that. 1 over b. If that suits you. However. All right, lots of extra working out there, but hey. Right, why is this one here? Because it had to, for me, it had to test the knowledge of substitution of negative numbers. This is one of the top 5 skills for entry into A-level maths that can often go by the wayside. So it's a substitution of negative numbers and therefore knowing what exactly you are putting. So how do we get about this? We're going to have to draw a series of things on the calculator to know like what we're doing. Okay, so here's my handy calculator. We're going to start by fractions. Okay, so we're going to press the fraction button, and that's going to open up like this whole open thing for us. And we can navigate using our navigation keys to either the top or the bottom, so the numerator or the denominator. We first start with the top one. If we navigate to the numerator, we'll obviously be typing 3.18 and then multiplied by, but then we're going to need to substitute a value in for y. Y is said to be -9. Now here's the key to doing this successfully. It's not about doing it as quick as you can without thinking too much. It's about really thinking ahead with brackets. So we're going to open a bracket, type -9. What have we used so far? There, open a bracket, and we're going to type negative, or you could use the negative up here, 9, and then you're going to close the bracket, and then we're going to click on this button here. This one is x to the blank. This allows us to say whatever is before it, we're going to raise it to a power that we are going to decide. So I'm going to press that button next, and then I'm going to type in the 12. Then I'm going to be using my navigation keys again, and I'm going to get myself down to the denominator. This is pretty straightforward. We'll type 3.7, so 3.7 as usual, multiplied by 12. You can write that just sure. We're going to go back to our power button and 9. So in total, the calculator will have this. And like, here's my tip. If in doubt, use like tons of, if in doubt, sorry, I had to get rid of that window. If in doubt, use tons of brackets, okay? So in a calculator display, like up here, this is what you should probably be seeing. You could put a bracket around the 12. You could put a bracket again around the two things that are being multiplied, like this. You can't really have too many brackets unless you're talking about brackets like this, where you're going to start to get confused about how many times you need to stop the bracket or close it off. But yeah, there we go. We're going to put that into our calculator right now, and we're going to see what we get. So you're going to do this as well, I hope. Some people may look at this and think, oh, I don't need to learn these sort of skills. And yet, mistakes are still made. But if this isn't the skill that you need to remember, don't worry. We have to write the full decimal calculation, by the way. Yeah, don't worry if this isn't. Just stick with it. It's nice to be confident about something. Nobody needs to knock your confidence. 47,044 00579. Okay, so that's great. We've got the full decimal, and I'm just going to confirm that here. Yeah, the full decimal displayed. Depends what your calculator is, but I've got 8 decimal places. Different calculators may give you more or less. Right, let's get this copied for another day. I'm going to go back to this one, see if it will work. Nope, it's still not working. That's really frustrating. I'll have to release these questions. I'll try again at the end, but I'll have to release these questions as pictures maybe, or individual videos. I really like this one. It took me ages to draw it. That'd be why it's corrupted. Typical, isn't it? Good luck to you if you get that question. Let me have a look at what other ones we might do first. We'll come back to this one. It's a tough one. So we'll come back to it. The box plot shows information about the length of time in minutes that some people are kept on hold when they contact a call center on a Tuesday. Okay, well, there's my washing course. My life doesn't stop for a live YouTube session. This is real life here, and there's always 10 things happening at once. So sorry for the bleeping. This is a box plot, actually box and whisker plot. These box here and then the whiskers around the outside. So these are the amount of times that people are waiting on average on a Tuesday. These are in minutes, and we need to find the interquartile range for the information in the box plot. What is the interquartile range? So there's something like knowing what each of these are on a box plot that helps, right? So this over here is what we call the minimum. So if you have a data set that these came from, some set of numbers, then this would be the smallest number, and we can see that that pertains to 25. This here would be the maximum, and this is 65. Can I just tell you right now that the minimum and maximum are pretty awful. If you're going to describe a group or a data set, please stick clear of them. They're not very accurate at all. I could give you an example. You've got a group of people, and they're all lined up, and maybe they're dancing. I don't know what's going on with the drawing, but they're all lined up, and you say, okay, which one is going to represent the class? If you're talking the Olympics, let's say the running track Olympics, you might pick the fastest person, happens to be this person here. That all makes sense. Would you say that they represent the group? Well, in a tournament where you send your best, maybe that's the case where you want the maximum. But if we're talking about their scores on a maths paper, and you wanted to know what this group did compared to another group over here, and you need a single value to represent those two groups, by only picking the person here that did best in maths, you're not being representative of everyone in the group. And so it doesn't make sense to use a maximum. If a person is being picked at random from this group to perform, or to just as an average, the maximum doesn't always represent that group. And or if you're picking someone at random, you could have someone vastly different from the maximum. Same over here. So really, there's a long discussion to be had about what number represents a group. And at the moment we go geometrically. We say, okay, the mean is right in the middle, the median is in the middle. So we add the 2 up, we divide it by 2 to get the middle point, or we add the 3 up and divide it by 3 to get the mid of the 3. It's a concept and it's not set in stone. You can argue it, but the minimum, maximum, not really good measures of this data set. And sadly, another thing that you would learn in primary school, straight line though, is range. So the difference between the largest and the smallest, not really contextually sometimes it can be good, but not really a good measure for comparing box plots. So be aware of what is a rigorous measure. This is what we call quartile 1. In other words, the lower quartile. This is what we call quartile 2. In other words, the upper quartile. And I suppose we should put in here what it represents. This represents 25% of the data, and this represents 75% of the data up to this point. The last one is the median in the middle. So we call that quartile 2. I don't know why I did that. It's quartile 3 up there. And this is the median to the very middle. So these are what are represented on a box plot. And that's the 50% point. So if you're thinking about the interquartile range, it's the range, how much it's spread out, so inside the quartiles. And it's probably a good idea to have these written down at the bottom. So this is 35, this is 45, and this is 55. So we've got our quartiles. The interquartile range is equal to the 2 subtracted. 55 subtract 35, which is 20, which is the width of this box. Each of these are 5, 10, 15, 20. The interquartile range is seen as more important than the range. It represents a large amount of people. It's 50% of the people that are around the center point, the most average area. As we say, if we value the center, and which you do at GCSE, so you have to take that on board. And yeah, so we have the 20 as the interquartile range. So there's a lot about box plots, but the reason why I do this is because, if you didn't know, now you know. And second, that you need to know a little bit more than just how to do that to answer part B. So the call center HR department published the following statement to their social media. Only 25% of our customers must wait longer than 56 minutes. I'll let that sink in a bit. It's these worded ones that really get to you. Comment on the validity of the claim. You must explain your answer. So we only have 1 mark for this one. Yeah, I took a drink. Nobody wants to hear that. So we only have 1 mark. So what are we going to do? We're going to think about what 25% is. 25% of our customers, that's the top over here. So let's highlight that. Why haven't we used blue? This is the top 25% up here. Okay, and that starts at 55. So what does that mean? Well, according to our data, the top 25% starts from 55 upwards. And here it says only 25% of our customers must wait longer than 56 minutes. Well, according to the data, 25% of customers wait longer than 55 minutes. So I'll give you a second, just think. Is that statement that they said, is that true? Is that fair to say? Is it misleading? Another drink break. Oh, it's been so busy today. And I forget to drink sometimes. Make sure you're all hydrating. That's what I can say. Comment on the validity of the claim. Explain your answer. We've come some way towards explaining. The data says that 25% customers must wait longer than 55. This says it must wait longer than 56. I would call this an injustice. Because the lower that this is, the better it is for the call center. So if they're quoting 56, they could have got away with 55. In another way of looking at that, and we will just estimate this, we could say that it's slightly less customers wait longer than 56. Remember, this is just an estimation. So if we go with a 56 that they've quoted, it should be more like 24% wait longer than 56. So this, far from being a lie or maybe manipulative, is actually an injustice to the company. So they're not really being fair. I mean, a lie is a lie. If you've got to be quoting something, you've got to be accurate. The world deserves the truth, right? Am I right? I think so. Okay, circle theorems. Yes, they might come up. Don't think they won't. What is going on here? Well, we'll find out. A, B, C, D are points on a circle with center O. AOD is a straight line. AOC. It's meant to be AOC. What's going on, typo heaven? AOC is a straight line, and I don't mind saying it. AOC is a straight line, and it is, because you can't have AOD as a straight line. Well, that would be called misleading diagrams. Angle BAC is 3x, and angle BDO is x. So that's all labeled on there, which is fantastic. Work out the size of angle DOC. What is DOC? Always good to know. DOC. All right, this one here. Work out the that one. And in terms of x, you must show all of your working out. No problem, mate. How do we make this more interactive? What do you do first? Anyone still in chat? What are you going to do first? No ideas coming forth. That's fine. If you're here watching at home, absolutely fine. You get given 3x, you get given x. I suppose there's a couple of things we need. Ideally, what we need is something to do with this triangle overall. We need to get ourselves in there. So I'm thinking this 3x could play a part. So if we think about this here, between B and C, we have a subtending angle there, which also subtends over here, right? So if this is 3x, this is also 3x. Draw a line for OB. Let's have a look. Oh, let's have a look at that. Be nice if it was a straight line. Let's use my old thing that usually straightens up. Can move it from that. Okay, draw a line there. Gotcha. Then what are you doing? I suppose you're saying that that's x now. Oh, that's going to turn away because I've got to take off drawer mode. Okay, that's x because we now have a radius here and here. Yeah, that works. So we've got 180. That should be equal. Subtract 2x. That's what that total is there. And then we're going to divide that by 2. That whole thing. I'm going to double check this is actually a thing. Is that x though? That's the question. Is it possible that that is the wrong angle to say that that's x? Don't think so. It joins with a straight line. And then this here would be half. So 90 minus x. I think that's pretty valid. That would be half of the whole thing. Thank you for your suggestion. I like it. Where was I going with this one? Don't know. You just don't know, do you? You've got 4x here. There's a couple of things. Sometimes you don't know where you're going and you have to just put something down. I'd be interested to see what I can get out of this though. This whole thing is 90 degrees. It's nice to explore this rather than just get through the questions, because you never know. This won't be the question. It could be something else. So let's see how many circle theorems we have in here. This one's 90. So we can see 3x and 90. This one here then is going to be 180. Take away 90, take away 3x. So this one's 90 subtract 3x. You never know what you're going to get asked for, I guess. We know that that's not. That's a really good call to bring that in there, but I wonder if there's another way of doing it. I suppose technically this now is 4x. Actually, no, you can't say that because we don't know if that's a radius. There's some subtending angles here as well, isn't there? That one goes there, but it also goes there. And that doesn't help too much. Another subtending angle here with that one. There's not too much to do about this one. Though we found it anyway. I do believe that was a very nice way adding in that line there. And that was x. 90 minus x as well. Brilliant. Let's have a look. Next one. Have you ever seen this before? This is a diagram of a shape called an octant of a sphere. So an octant of a sphere is, an octant in itself is where we split something into 8 equal parts. You get octants of a number of different things, but of a sphere, we get this shape here. So imagine this up here, and you split it like that, and then you split it again this way. You'd end up with this shape here in the corner. That's the base of it. And that's what you have here. So this shape can be thought of as a quarter of a hemisphere. Very useful. With a radius of 5.6 centimeters. And we have to work out the surface area of this shape. We'll give your answer correct to 1 decimal place. Okay, so we think about how many sides we've got. And it would be nice if this didn't slide around. We have a straight side, a straight side. You know, I'd love to be able to draw properly on my tablet, but YouTube says that you need a certain number of subscribers to go live on a mobile platform. Well, guess what? I'm on a laptop. That's a mobile platform. So what's the problem with a tablet versus a laptop? I just don't know. Maybe it's just to annoy people. Right, that's the best I can do. There's 1, 2, 3 of those. And they're all the same. The sphere can go in any direction. And we're thinking about the dimensions of each of those, 5.6 in all sides. Technically, these are a quarter of a circle, right? So in order to find out one of these, we're going to a quarter of the overall circle, which would be pi r squared in terms of area. And that's just one of them. We get calculator out and we can work that out. So we're going to be writing 0.25 multiplied by pi multiplied by r squared. So open the bracket, 5.6 close bracket to the power squared. Okay, so it's not the nicest of things. And I'm going to write it as a fraction because it's easier to get to later if we want the full decimal. So this is our standard form. And if you want to look at it in decimal form, it's something like 24.63, etc. All right, but we want 3 of those. So we're going to have 3 multiplied by 196 over 25 pi. We get an expression which is 588 over 25 pi. So this here is useful. It's, should we call it all the flat sides, all the flat, and if we want to be technical, faces. And the last one is the curved part. So this whole curved part here, up at the top. And this is going to be part of the surface area of a sphere. Thankfully, you get given these things. The surface area of a sphere is 4 pi r squared. So the surface area in total, 4 pi r squared. We do have the radius, which is 5.6. And because we've got a certain amount here, as we said, we're going to split it like so, so that we have 4 curved areas on a hemisphere. There's 8 in the whole sphere. So we have to divide this by 8. So we could just write this at the front. In other words, it's multiplied by an 8th. We want the surface area of just this up here would be this calculation. So again, we're going to put the calculator to the test. 4 over 8 times pi times bracket 5.6 squared. We can add that together. Bear in mind, my calculator currently has this on the display. So I could, at this point, say add, and then put this into a bracket, just to be careful that I'm doing that whole thing. 4 over 8 is 0.5 multiplied by pi, so shift and pi, multiplied by open bracket 5.6 all squared. So I've added that to my previous answer. So I've input this, just to be clear, and then I add, I press the answer button because this is still in the answer. What that would be, to press enter, and we get 196 over 5 pi. Now this is needing to be to 1 decimal place, and it's a surface area. And we're dealing with centimeters, so it's going to be centimeters squared, because it's an area. In order to change this into a decimal, you have to press the S to D button. okay, which is 123.15, and I'm going to do the whole thing, 0432 centimeters squared, and if we round it to one decimal place, 123.2 centimeters squared to one decimal place. Lovely. These are typical, aren't they? On the calculator paper, very typical, the kind of ones that you're going to be doing. You've got calculator use because of the decimals. Okay, question 2. Simplify the following fraction. Couple of skills here, and these are not skills that your calculator helps you for. So as well as the skills that your calculator brings, this exam will try and test you on questions where a calculator won't be useful. This is partially one of them. Although you could argue that if you get rid of the top and forget about that, the bottom one you could solve using any calculator actually these days will solve a quadratic, and you could use the roots to reverse engineer what the fractions would be inside the brackets to factorize it. So it's possible that whenever it says simplify fractions and you're looking here algebra, okay, all of this is going to indicate that you need to factorize, and that's quadratic factorization. On the top, it's not really that difficult. Some of you might be thinking the difference of two squares, but there's not a squared on top, so it's definitely not that. This is plain factorization. So let's take a 4 out and a y from both, and what we're left with is y subtract 4. Okie dokie. On the bottom we have another quadratic, and we're going to have to factorize it using a particular method. Depends what you're after. As I said, let's go through quickly how you do it on a calculator. So you go to menu, and this is on the 991EX. Very similar on other models that are similar to this. Class Wiz, the CW is slightly different, but we're going to go down to equation. So that would be equation slash function. Press equals to go in, and then we go to polynomial because a quadratic is a polynomial, and that's actually number 2 as an option. And we're going to select 2 degrees because it's a quadratic, specifying, and we're going to type in our values 2, 6 and -56 and press equals twice. It tells me that x1 equals 4 and that x2 equals -7. 2, 6 minus 56. There we go. So in this case we have an interesting scenario which you didn't account for. I can tell what's happening here. This 4 and the -7, you would probably expect a fraction, because clearly if there's a 2 in front of the y squared, you're looking to have a 2x at least in one of them, which implies a division and later. So how we're going to use this is realize that 4 times 7 is not going to get us to our -56. Definitely one's positive and negative. In fact, this ought to be 8. Okay. We also know that this is a prime, so we're looking for, when I say x1, x2, that's the calculator writes that. Technically we have y1 and y2. We up here will have a 2y, and this is me just at the side just thinking out loud. So we've got, to get this term we need a 2y and a y. To get the term that we have over here, the 56, The 7 is fine, but the 4 is not. So if we say that 1 is -7, or if we say that one of them is 7, what we would need in the other one is an 8. And this would actually fit really well, because then we'd have 8 divided by 2. But how do we go from these back into up here? Well, if you go from this, you would set 2y plus 8 equal to 0 and rearrange it. So we could do that the same here. We can rearrange these equations so that they equal 0. So we get y1 minus 4 equals 0, and y2 plus 7 equals 0. So this is what we would have had to put equal. So this one's going to be a positive 7. And since this has to be 2y, we're not going to put negative, but we're just going to double it, and that would make sense for us. If we double this, we have 2y minus 8, and we have the same information, but this will be our question. So do you like using the calculator for this? I feel like it can be a little bit maybe a bit long-winded, but you know, if you're really desperate to use a calculator for it, you can, and that's how you do it, and it won't always be as tricky as that. Okay, so what we're expecting here are these to cancel, but it doesn't, and that's because this is not fully factorized. Okay, so if you follow the methods and you don't have a calculator, you would probably do it this way. You'd say 2 times 56, which is 112. And then we've got factors of 112. So 2 and 56, obviously. 3, 4. We could double that, so we'll half this. So 25, 28. And then we've got 8 and then 14. 16 and 7. Okay, so we've got to look at the two that have a difference of 6, and that's those two. So we're going to rewrite that 6y in terms of 8 and 14. What goes best with it? I mean, for sure 8 goes into 16. I think we're going to go with 14. So to get to 6, we're going to do plus 14y, subtract 8x. That will get us the 6y, 56, like so. Let's move this out of the way now. And factorize the left-hand side. So the 2 and the y come out, and we're left with y plus 7. Out here, we've got the negative 8 comes out, so we're left with x plus 7 again. And then 2y minus 8 x plus 7. So we get to the same conclusion, but do we spot that this one needs further factorizing? And that's really the key. We'll move that aside. Let's have a look at it. Obviously 2 comes out as a factor, right? So we've got 2y minus 4, and we would be looking for this to simplify, right? So I saw that y minus 4 was on top, and it had to be one of these two. It can't be this y plus 7. It's prime. So it gives you a hint of where to go. A little bit more simplifying to happen. 4 divided by 2 is 2. And then we don't have these anymore. So the only thing left is y plus 7. And there we go. Fully simplified. As I said, factorizing whenever we are doing these, especially when it's quadratic. We've done a lot so far, haven't we? I've gone over the time that I said that I wanted to do this for. I'll do one more question. There's a lot of questions here, and we've got another 20 actually. That will be available on Patreon. These pages aren't working again still, so I can't go back to them. Apologies. I haven't done this one yet. This one's still available. And we'll finish with just this last one. Hopefully I can write. Yes. Whew. So, as I said, there are these questions plus like so many more, and the fully worked solutions all on Patreon, and it's fairly cheap just to get hold of them. It's the smallest tier is the one. It takes a long time to make these, so it's a great way to give back and be part of a different community with a ton of resources, and one-to-one support and extra live sessions on there. So definitely go ahead and check it out. So question if you want. Question 13. A bakery has opened up a shop in Cornwall. Yeah, this is real life applied maths. If you've never been to Cornwall, you've got to go. It's amazing. Beautiful place. I'll post a picture up on my Instagram. Should I do a picture? No, I'll put it on the story of Cornwall when I went recently, just last weekend. Beautiful. The shop decides to open a day earlier than scheduled on Sunday before the high season starts to test which products sell well. So on Sunday, that's still pretty good. 70 customers ended up buying their products. And it's quite useful to test it on this sample. You can see where it's going. You can think, well, if I test it out on this, I can then make some purchases ahead of time. So this is a true story, right? I was in a pastry shop by the coast, and they had a range of pastries smelling good. I'm hungry. And I overheard while I was eating mine, I chose chicken tikka, by the way. I overheard somebody say, those chicken tikkas are selling out like wildfire. So I was thinking, wow. You can see that reflective here because chicken tikka has got the highest frequency. But it's a true story. They would want to know which ones are selling more so that they could then bake more for the afternoon, because they knew in the afternoon there are a ton of people coming for their lunch. Well, it's kind of a little bit like this, but we're talking about the season ahead and knowing what ingredients to buy or what things to make. So these kind of things are inferential in a way. We're taking what we call a sample, okay, and we're using that sample to say that it should be roughly the same proportions when we let it on the public at large, or a larger proportion of people, what we might call a population. So we can use this. Now, what kind of maths allows us to use this as probability? It's relative frequency. Okay, so relative frequency. And it's a way of turning a sample of frequencies into relative fractions, like standardizing in a sense. They're all out of the same total. Because remember, there were 70 in total here. As an attempt to estimate the proportion of people that will be interested in this if this sample is representative, right? So if I go to my calculation, and so I look at 25. 25 out of 70 were purchasing chicken tikka. So I can write that as a fraction, 25 over 70. I could then simplify that fraction or turn it to a decimal more appropriately so it's easier to see, as 35, I'll be a bit more accurate, 35.7%. All right, so 35.7% gives you an idea of what it is. It's also a probability, isn't it? So whenever you see a fraction, a decimal, or a percentage, it's a probability. So there's a 35, according to this sample, a 35% chance that somebody will end up buying a chicken tikka. And we probably think, based on this sample, that's a good proportion of this 315. It probably is going to be roughly the same. What's the question focus on, though? The question focuses on how many will want to have a traditional Cornish pasty. Well, that's hard to say. Like, you got to remember there's limitations here, but we'll talk about that in a second. Here's the traditional Cornish pasty. Anyone know what's in a Cornish pasty? Because I asked. And it's, these ones are really good. These ones were steak. So full proper steak with neeps and tats, I think. So you've got potato, swede, carrot. Had all sorts of veg in there. So it's root vegetables and a bit of meat. Really tasty when it's homemade. So a traditional is 20. So what we want to do is turn this into a probability or a proportion, however you want to look at it, by dividing it by the total. So we get 20 over, I'm going to make that look like a 20. 20 over 70. Put that in our calculator. I can give you that as a decimal. And that's 28.57. Let's just say 57%. Okay, so I've turned it into a percentage. I'm going to leave it on my calculator because currently on my calculator it's displaying 0.2857, and clearly this is ready to go. 14 ... This is ready to go for my next calculation. On Monday, the high season begins and they expect to see 315. So based on the idea that we expect 28.57% of people to go for a traditional, the calculation is 315 multiplied by the number on my calculator, which is the answer button, which if you want to show you're working out, you're going to be writing the actual decimal. Can't actually access that button right now, so I'm just going to write it again. 315 multiplied by 0.285714, etc. I did 315 over 70 times any given filling. Where's the 315 come from? That's the number, right? So let's if we do that, 315, and you're going to multiply it by any filling, call it x, over 70. That's the formula, right? So in essence, if you can rearrange that to be what you did, that's fine. So you could easily do that. Let's say that's 315 over 1 times x over 70. You can rearrange that and say that's 315 over 70 multiplied by x over 1. And we all know that you don't need the over 1 bit, right? So in essence, it's the same thing. And you know, that's one way of doing it, is finding what that conversion fraction is for sure. From a first principles point of view, this is what you're doing, and you're finding the fraction of what the proportion is that it represents. And then to find a proportion of any number, you multiply it. And that will give you the final answer there. So multiplied by 315, you'll get the same doing it your way. That should be 90. Wow, that's really nice. 90 people. I don't say nice because 90 people is a good amount of people, just that it came out to be a whole number is a miracle. So good news. Yeah, really, we celebrate, you know, inclusivity here, like and finding your own identity as a learner by doing it in different ways. Like, there's so many ways of doing this. I'm here to say, here's my way, see if you like it. Maybe you get some ideas, you know, how you're going to do it your way. And that's all it is. State any assumptions that you made and explain how this may affect your answer. So what assumptions did we make? It's kind of the basis of inferential statistics. Just write that down so you know what I said. Infer, because you're going to infer things. You're going to use a bit of information to make assumptions. It's educated assumptions about a bigger, wider population. So inferential stats is where we use a sample to tell us about a population. I mean, relative frequency is pretty much that. It's one method of getting data in order to talk about a population. So assumptions that we made. We're assuming that these are the proportions of people that that will come in and buy that. We're assuming a number of things, I suppose, actually. We're assuming that 315 come in, but does that make much of a difference? Yes, it will make a difference on the 90, because if we have less people, the 90 will be less. It won't have an effect on the percentage that we estimate. But the problem is, whenever you do this, you can never guarantee that this is how it's going to continue. This particular, the assumption, the biggest one, is that this is a representative sample. This particular day is a Sunday, right? So if you did this on a Sunday, is that going to be the same people in the high season that then come on Monday? So there are some assumptions that you're making in terms of the sample and how it might affect your answer. So we've already talked about the proportions. They're not going to change really, but we're assuming that they're going to be representative. What might be really useful in statistics and STEM in general, and you want to look for something called replication. So this is where we can do multiple samples. So sample 1, sample 2, sample 3. And all of these may pool together to give us a more accurate. But what you're doing is you're looking at a population, right? So this is a population. And you're taking a sample from all of these areas. The thing that is wrong with the sample is the thing that's wrong with this situation, is that you could just be pooling from all the people that like chicken tikka fans, right? Chicken tikka. And they only exist here, okay? So this is the haze of chicken tikka fans. It's something like this. And your randomly selected days are just so happen to be the days that the chicken tikka fans come out of the woodwork. If you sampled from this day, you would have found the king to be the traditional. If you sampled, I think if you sampled on a Wednesday morning, you would get the sausage and beans gang. Okay, so that's a Wednesday morning. So it really depends. There's limitations on your sample, right? So if your sample came from a Sunday in the off season, maybe that sample is only good for when you have another Sunday that's in the off season. So maybe you're going to need a sample for every different type of setting that you might expect. You might have a sample for off season, sample for on season, and then variations on a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. You could think about mornings and afternoons. You could think about times of the year, because pasty is a warm product, right? So that's not going to be something people want in the summer as much as they do in the winter, but it depends where you are. Because if you're in Cornwall, that's where home of the Cornish pasty. So they might want it even in the summer. Really, it is the issue with sampling in general. Thankfully, if you take enough samples, 1, 2, 3, 4, and you find the mean of all of these samples, all of those means end up being normally distributed around something which is a very good estimator of the actual population. So you keep on doing those samples, people. You keep on replicating your experiments, and hopefully eventually you'll get some useful data. There's still a problem though. Sorry if you're feeling comforted by that. There's still a problem because it's, 2023? In 2024, fashion and trends. What else? Climate change. All of these things are still changing. So what is true of 2023, again, every year it might not be the same. It is a problem, but it keeps us on our toes, right? All right, I think I've pretty much exhausted myself. There are some tough old questions there. One last check to see if that question works. Where are you? This one is pretty good. This is a fish tank, guys. Okay, just so if you're watching this and you do end up subscribing to Patreon, and you want to get the rest of these questions with answers, this is a fish tank. Imagine you've got, I don't know, like sand at the bottom there. Why is it all at the bottom? They ask. These are fish. Because somebody's tilted it, right? So this would be the open top. And you can see that it's just about to pour out. Obviously, it's not going to because it's at that perfect point. And the fish tank has been lifted up like this. And a question that is being asked is, what is the height of the water if the fish tank comes back down to the horizontal? So what height would it be? So you want to draw yourself another rectangle and think, well, what is the height if that does come back down? So have a go at that one. Bless you all. There's the question. Print screen it or something. See if you get the right answer. The answers will be on Patreon, as I said. Where are we going? To that one page. Please work. Nope. Why? Oh, why? Delilah. We don't know. All right. So now we've come to that point. We've come to that point where we want to add a page for questions. So I'm here for, what's the time? I'll be here for 5 minutes. If there's no question in 5 minutes, we will end the live. Bring your own questions, yes? I don't even know what I'm doing here. What should we draw? I'll tell you what I'll do. I'll pick out a question, a bonus question for those people studying A-level. No, they'll never find it in here. Never find it in here. Because I may as well. Whilst I'm waiting for questions, and I'll keep saying that, I will go through some maths. I need to do this question anyway, just to check that it's correct. So, away I go. This, everyone, is called a piecewise function. And I have to turn this, what we call a cumulative function, into a probability distribution function. And if I can remember what they said, I think 2y minus 7, and then obviously 1 because it's cumulative, and it was up to 3 up to a, and then a 6, and then y is more than 6. Excellent. Okay, so these are constants, aren't they? Yeah, so because it's continuous, that's equal to that. Okay, so let's put in 6. 12, take away 7. 5, 20, 20k equals 1. Great. K is 1 over 20. If I put A in to this one, would that work? Would that work? If I put A into it, then A... Yeah, let's rewrite it. Any questions, guys? I'm here for questions. That's what I'm here for. If you have any questions, let me know or give me a topic. We could talk about it. We could talk about anything you want. Any strategies. Okay, by implication then, 1 over 20, that's 1/5. Any questions, guys? Any questions at all? Topics, let me know. Just a hangout place right now. If you've got any questions, let me know. Okay. Yeah, that should be the same. So if we put in f of a, we've got 1 over 20 a squared minus 2a minus 3 should be equal to 1/5 2a minus 7. Right? Because we're going to put a in here and a in here, and it's basically the same point. If we multiply everything by 20, that's 20 over 5, that's 4. That's 4 over there, so that's going to be 8a minus 28. A squared minus 2a minus 3. A squared. Is that right? Yep. And then plus 28 plus 25. Okay. A plus 5 squared. No, a minus 5 squared. I'm jumping to the solution. So a equals 5. That's any way around it. Useful. Hey, come on now, give me a pen. Any questions, guys? We're talking GCSE. Any topics, any questions, any advice you want, let me know. Just thought I'd do something that I need to do in the meantime. This is A level, so don't worry. You don't need to do this. Any questions? Where are we at to? Right, we've got all of this. All we have to do now is differentiate. Probably expand that. So 2 over 20, which is 1/10. Well, let's just write 220. 2/20th y. That's minus 2 over 20. And then that's disappeared. That's going to be 1/5, so 2/5. And 0 otherwise. Okay, I agree. That's good. I agree with the student. So there is another professor who has put the answer and they disagree with it. And so do I. Let's write this in here. We could take 2 over 20 out. Oh, actually, let's take a 10th out. Let's take a 10th out, and that would be 2y minus 2. Yeah, totally agree. That's it there. That's the 2/5. Excellent. Okay, it's been 5 minutes, everybody. So thanks very much for coming along. If you wanted to know what A-level statistics looks like, it's this question here. This is turning a cumulative function into a probability density function. And you're only really going to do that if you do further maths. Okay, thanks for coming, everyone. Hopefully it was useful. There's some more questions. You can look through them. They provide extra, all right? Good to see you.